Hi, welcome to sort of the first episode of Theory. This is sort of an idea that was given to me by a friend of mine who's really sort of struggling in her theory class, and made me think that maybe there are a lot of people out there who want to understand music a little more and really get into this a bit. And I wanted to make some vlogs about that, so I'm going to. And what I'm going to start off this first episode with isn't really anything really theory. We're not going to get into, anything interesting like, well, we are doing a lot of interesting things, but anything like scales or modes or intervals or, stacking chords or things like that. We are going to talk today about physics. So, I know what you're probably thinking is, oh boy, physics. But, physics is probably the most important thing in music, because all this is really generating sound waves and the interaction between sound waves and the science of it. So, I'm going to start off by actually explaining a bit of the science behind this. So, we have our fun sound wave, which we get by vibrating air molecules at school. But we have our sound wave. Yep, and there's our sound wave. Let's make him a bit more even there. Alright, this is our note. This is, for the sake of time, this is going to be C. More accurately, middle C. Our sort of note that's going to be right about there. Okay, but what happens in music is really, for the harmony and whatnot, is how these sound waves interact with each other in harmony. So, if you get a second sound wave. Now, if the sound wave looks like this, something like that. You see how that's really close together? How these points here are very, very close together? That means this note is probably pretty close to being just a unison. It's probably just a little off because they're not exactly right on top of each other. But this note is going to sound pretty much the same as the first note we started with. But if our second note looked something like that, you'll notice that those don't line up at all. And that means that we have a pretty dissonant interval. We have two notes that are probably not really related to each other. We probably have something kind of like, I don't know, this, or that going on, or maybe even, something really that dissonant. I don't think this would be that dissonant though. And that's what harmony sort of is, the interaction between these notes. Now, the phenomenon that we sort of explained there, this reason we have this dissonance is because when two notes interact, they create what's called a beat frequency. And this can be really explained better. I'm going to take my hat off. I don't know. I was wearing it. It can really be explained better when, in terms of the guitar. Now, what we were playing there between C and C sharp is a minor second. It's the closest interval that we have in Western music. And what if you can hear, you can hear this better on the guitar, I think. But if you can hear, there's a shaking in there. There's a vibration in there, as opposed to there isn't really a vibration. It's the same note. that's because of this beat frequency, like I was saying, because when two sound waves, like we showed there, interact and they don't match up, the crests and troughs of those waves sort of start to cancel each other out or amplify each other to create sort of a whom, whum, whum kind of thing, which sounds pretty cool. And that's really one of the things we try to work with in music, is how to control that. And I was using the guitar as an example, is like when you're tuning your guitar. I'm going to detune this just a little bit. When you're tuning your guitar, there's that wobble, and you have to just try to get rid of that. All right. So what I'm going to talk about now is the relationships between notes that actually sound like they're supposed to go together. Alright, so as I've sort of been talking about, there are intervals and relationships kind of like this one that just don't really sound that close together, don't really sound that nice. However, there are relationships sort of like that do sound very nice, and that is because their sound waves match up better. That is because when I play, for instance, what I just played, a G and a B, there is a beat frequency created, there is a vibration, but that vibration is not so abrupt and violent that it messes with your inner ear. It sounds pleasing, it sounds nice. Same with E and D, fifth. And as long as you have another note in there also, same with E, for example, G, B, and F sharp. Because you have a fifth here, just like I had here. See how fifths sort of sound really, really close, because they're almost exactly halfway between the octave. What is actually halfway between the octave? Sure, octave are the same note. So if I go like, what is actually halfway is a very dissonant and very cool thing called a tritone, which I will get to in another episode. But there's all these sort of nice sounding intervals can be built on top of each other to make a major scale. We have our unison, our major second, major third, perfect fourth, perfect fifth, major sixth, major seventh, and our octave. And we build that major scale by just putting those notes that don't sound very dissonant and don't sound like our tritone to be like our tritone or our minor sixth or our, I don't know, our minor second, that don't sound conflicting, that sound like they match up very, very, very well. That's why we build those into our major scale. Alright, so going back to our magic whiteboard over here, we can sort of show with those sound waves again. We're going to have our one sound wave here, our C. I've been trying at least to base most of this on. Have our magic C over here. And the reason that those notes sound right, like the fifth and the octave and the third, is because when you put their, I'll start with the octave first, when you put their sound waves up along in here, see how that octave is actually matching up in all of the right places. And that is because its frequency is exactly double our original note. So we can have, they still match up even though they're different frequencies, and they will create a beat. That beat will match up. And if we take, I need an eraser. Now, if we take our C again and put something like, take our C, and we'll use our third, which will be you see that part of the time, especially like here, it'll match up. Not all of the time, but enough to create not necessarily the same like equal harmony that the octave or something like a fifth would create, but would create enough harmony to not create that dissonant feeling in your ear and not make you go, no, stop, that doesn't sound right. Because it sounds very nice to our ears. And that's how sound works. So I hope you learned something. I promise the next one won't be about physics, although unless people post and comment and just give me ideas, I don't know what the next couple are going to be about. So please do that. Subscribe, I guess. Whatever. Have fun.